Friends, welcome back to my channel. In video number 856, I explained push-pull converter topology, and I received a comment from my viewer saying that he loves my videos, but this video, it have some blur explanation. So that is the reason I am reproducing this video, and today we will discuss in detail push-pull converter topology. When we need 500 watts or more than 500 watts, we use push-pull topology. The unique thing in this transformer that it have center taped transformer, center taped winding in primary and center taped winding in the secondary. The dot direction here, this direction is here, this dot is here, its dot is here, its dot is here. And these two ends, this end and this end of the transformer, are connected to switch, any type of switch. MOSFET, IGBT, transistor. This end is positive. In the secondary, we have one diode here, inductor, capacitor. This is our load in parallel to this capacitor. Here we have second diode, this inductor, Q1, Q2. Q1 and Q2 have opposite drive. When this will turn on, this will remain off. When it will turn on, it will remain off. And between both channels, there is very small amount of time that is allocated when the both channels are turned off. This is 1/2 cycle. Q1, when this channel will turn off, after a specific time, the second channel will turn on. When it will turn off, after a specific time, this time, this allocated time is called dead time between both channels. Q1 will turn on, Q2 will remain off. Then the both channels will remain off. Then Q2 will turn on, Q1 will remain off. Then this is already turned off and it will be turned off. So this time is called dead time. When this Q1 will turn on, this is turn on time, Q1. At that time, what will happen? This battery current will start through Q1 and it will flow the winding in this portion. So now winding this end is negative, this end is positive. We allowed a current flow from this portion, but that time we will follow the dot rule. If this end is positive, winding this end will become positive. Respectively, this end is negative with respect to this voltage. The same way in the secondary side, this dot, this is now positive. Respectively, this end is now negative and this dot side is positive. Same way, this is now negative. We allowed current flow from Q1. We produced magnetic field here, the core magnetized, and the winding this end will receive voltage in this polarity. Why? Because its magnetic field will cut this portion. What will happen now? The current will increase linearly. Why? Because we have inductive reactance here. So current will increase linearly. IQ1. Now let's see the secondary side portion, and then we will come to this portion. We can say this is D1, this is D2. When the voltage are transferred here, this end is positive now. If we see, this diode is now forward biased, and this diode is now reverse biased. So D1 will allow to flow the current. When it will allow to flow the current, this end is now positive. IL, inductor current. In the inductor, the current will increase linearly. Why? Because it have inductive reactance. Now this diode is reverse bias, so it have no effect. The current will flow from this portion to the capacitor. It will charge the capacitor and it will provide the load current. Secondary, this side will drive the load using D1. We discussed this end is negative, this end is positive, so this end is now positive. Now if we see from this end, positive, negative, positive, how the circuit will work now? We have one battery, positive, negative. This battery, we allowed current using Q1. For example, these are 300 volts. These 300 volt are here. The same voltage will produce in this portion because both winding turns are equal. So the magnetic field here will cause to produce same amount of voltage in this portion. Now this is battery, and now this is negative end of this winding. Negative, positive, negative, positive. We can say two batteries are in series. This is equivalent circuit. These positive voltage are reaching where? At Q2. So Q2 will receive double voltage stress. If this is 300 volt, this portion, winding this portion will provide same amount of voltage. Now the both sources, battery source and this EMF source, are in series, so Q2 will receive double voltage stress. Here is Q2. If this is V in, at that time it will receive 2V in. When this turn off time will arrive, Q1 will turn off. The current will stop. The magnetic field stored in the core in the winding will collapse. When it will collapse, it will produce reverse voltage to the applied voltage. Before this end was negative, this end was positive, but now the voltage polarity will reverse. Winding this end will become positive, this end will become negative. When this end is negative, here in the parallel of both switches we have recovery diodes with Q2 and with Q1. Now this voltage, negative side, is reaching to cathode. It will discharge, it will demagnetize the core, because the voltage produced will take easiest path to ground the voltage. And if we see this diode, this is now reverse biased and this transistor is now open. When it is open, Now what will happen, because this end is positive, this end is negative, so negative voltage will reach to cathode of this diode. Before this, when Q1 was working, positive voltage worked at the cathode, so it was reverse biased. But when Q1 will turn off, the magnetic field will collapse, this diode will give easiest path, so core will demagnetize. Same time, the polarity here will also change. Now this end will become negative, this end will become positive, and at the same time inductor magnetic field will also collapse. When it will collapse, now we can see this end is negative and this end is also negative, so this diode will not work. Now this negative and this end is positive, so at that time this diode will demagnetize the core. At that time, when Q2 recovery diode will discharge, at that time applied voltage will reach to this Q2, so V in same voltage will reach here. Now this core is demagnetized, it is now neutral, winding don't have anything and this winding don't have anything. Both transistors now will receive 300 volts, which are applied voltage, through winding this portion and through winding this portion. Same here, in the first half VDS1 will low. When VDS1 is low, that means it is saturated, it is turning on, and in the primary the current will flow linearly as we discussed here, and VDS2 will receive double voltage stress as we discussed by this example, and the load current will increase linearly. Now Q2 will switch. This time ground side, the negative side, will reach to this dot side. When it will reach at this side, and we have positive voltage here, so current will flow in this portion. This dot is negative, non-dot side is positive, so non-dot side here will become positive. The same way, the two voltage source will become in series and Q1 will receive the same voltage stress, same as Q2 was receiving in Q1 turn on time. Now Q1 will receive 2V in. Here is V, here is 2V, double to the applied voltage. Now let's see the secondary side. This dot side is negative, this dot side is negative. Non-dot side is positive, here positive, and this non-dot side is positive. In Q1 turn on time, D1 was forward biased, but now D1 is reverse biased. And if we see D2, D2 is now forward biased. Positive voltage will reach here at the inductor. This end will become positive, this end will become negative, so voltage will pass to the capacitor and load. The current will flow in the inductor, capacitor, load through D2 and this portion of the winding, secondary side. And the same double voltage stress, positive, negative, positive, double to the applied voltage stress will there on Q1. This is the dead time when Q1 is turned off. After that, when its magnetic field will collapse, it will receive a spike, so that will be discharged by Q2. But now when Q2 will turn off, now because these have to work in opposite direction, if this is on, this is off, this is on, this is off. Now when Q2 will turn off, now magnetic field will collapse. When it will collapse, it will provide opposite direction voltage, so voltage polarity will reverse here. Winding this end will become positive. When it is positive, This diode is reverse bias, Q2 is off now. This time these voltage will discharge through this Q1 recovery diode that is parallel to this switching device. It will demagnetize the core, and same way here the voltage polarity will change for a while, that is dead time period. Now this diode is reverse biased. This magnetic field will also collapse. When it will collapse, this core will demagnetize using D1. In one cycle, complete cycle, that is composition of Q1 on, dead time, Q2 on, dead time. It is a complete set. After each switching half cycle, there is dead time. It will cause to produce 2 time pulses in one cycle, one switching cycle, that is composition of 2 halves. Inductor will receive 2 time pulses. When we have high frequency, at that time the ripple voltage are decreased. So this is the benefit of this topology, that it provides low ripples in the output. When this core is demagnetized, at that time it will become ready for the next cycle. So this will turn on the same process, the first process it will start. In each half cycle, the opposite transistor will receive double voltage stress. This is the drawback of this topology, is that the switching device always receives above than 2 time voltage as a voltage stress. When any switching device have high voltage on its channel, when it will turn on or turn off, it will not turn on immediately. It will take a time, turn on time, to reach from its 10% to 90%. So this portion from 10% in the rising edge and also in the falling edge, at that time its channel resistance will vary from high to low or from low to high. When it is turning on, before turning on its resistance was very high. Now when it is turning on, it will not turn on immediately, so its resistance will change in this time. At that time, because when we have resistance I square R, it will dissipate power. Same way in the turn off time, when it was working, its channel resistance is low. When there is low resistance, that time it will not dissipate too much power. But in this portion, when we are turning it off, its channel resistance will increase from low to infinity or high resistance. At that time it will dissipate power. Why? Because we have double voltage here. When we have more voltage, V into I, that will cause to dissipate power. So this is the drawback of this topology. If we see this topology, we are driving this transformer 2 times in a cycle. In half cycle we allow current from this direction, second time we allow current from this direction. So current will change in 2 directions. So its magnetic field will change north to south, south to north. So its magnetic field will keep swinging. So this swinging magnetic field, when we have more strong magnetic field and it is varying all the time, at that time we will receive more induction in the secondary side. So this is the benefit of this topology. If we compare with flyback, in the half portion we switch the transformer, and in the 50% duty cycle we demagnetize the core. But this topology, it will allow a very small amount of time to demagnetize the core, and same time it will produce another switching cycle. So by means of bidirectional switching, we produce bipolar magnet in the transformer, so it produces more power. I hope you enjoyed this video. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.